the CEHF Blended Learning course, Health-Related Physical Fitness Assessment and Programme Design. This is Lesson 2, which is the Principles of Training and the FIT Principle. The aim of this session is to provide the exercise and fitness instructor with the knowledge of the principles of training and the ability to apply the principles to the health-related components of fitness, which we covered in Lesson 1. The learning outcomes. You will be able to define the principles of training. You will be able to describe and apply the principles of training to the components of fitness. And you will be able to apply the FIT principle to each of the health-related components of fitness. The principles of training are guidelines used to assist individuals improve their fitness and performance. They are the bedrock or the foundation upon which all good exercise programs should be based. So the first one we're going to look at is progression. As a person becomes fitter, a higher intensity of exercise is needed to create overload and hence improve fitness. Now there are some key areas here that we want you to look at. The first one is intensity, the second one is overload, and the third one is to improve fitness. So the first thing I want you to think about here and to briefly write down what you think intensity means. So you can pause the presentation, take a piece of paper and a pen and just briefly write down what your interpretation of intensity means. You're going to leave this aside then and we're going to come back to it. The second one is specificity, and this is the result of the type of exercise performed, is specific both to the muscle groups being used and to the energy system involved. For example, if a client's goal is to run a marathon, then their main method of training has to be running, or some method which improves the cardiorespiratory system. And generally what a person does if they're trying to complete a marathon is they combine different methods of training the cardiorespiratory system. Reversibility. The training effects gained are reversible if workouts stop. For example, if a person becomes injured or sick and they have to fall out of training for a number of weeks, well then they will lose their fitness. But if they revert back to their training schedule again, they will gain their fitness back quite quickly. Placement. This refers to the scheduling of the training within a week, a month, and within each session itself. Individual differences. Each person has different capabilities and will adapt in a different manner, and therefore there is no one-for-all program. Adaptation. This refers to the way the body changes as a result of training. For example, muscles become stronger, the heart becomes stronger, etc. Overload. This is a very important principle of training because in order to improve, a person must work at a greater load than normal, and this is achieved by the use of FITT. Another task. Briefly write down what you think FITT stands for. So you can pause the presentation for a few seconds while you do that. Moving on, just to check your answers. FITT, well the first one, F for frequency, is how often you train. Intensity, which is how hard you train. And I want you to refer back to your answer for the previous first task that you did, which was to write down what your interpretation of intensity was. So this means how hard a person trains in each session. The first T refers to time, so for how long did you train? And the second T is the type of training you did, the mode of training. Was it aerobic training? Was it circuit training? Was it resistance training? So now we're going to move on to the application of FITT to the components of fitness. And the first one we're going to look at is cardiorespiratory endurance. So the first part of it is frequency. We're going to try and train for 3 to 5 times per week in order to improve our cardiorespiratory endurance. That is the recommendation. the intensity. If you remember what intensity means, how hard we train, well then we're going to try and train between 60 and 85% of our maximum heart rate. The time we train is very important. So for moderate type of training, we're going to try and keep going for at least 30 minutes up to 60 minutes. If the exercise is very vigorous, well then maybe 20 to 60 minutes. And the type of training is going to be mainly aerobic, for example, running, cycling, swimming. Okay, so we're going to come back to maximum heart rate. We referred to it there in the intensity of the training session for cardiorespiratory endurance. Well, what is maximum heart rate? The maximum heart rate is the maximum amount of times your heart rate can beat in a minute during exercise. You will find out your maximum heart rate by doing a VO2 max test, which is a fairly expensive type of test that you can do in a laboratory situation, or very simply by subtracting your age from 220. The next task I want you to undertake is to look at 220 minus your age and write down any disadvantage or any limitation you can see within that formula. Just take a few seconds, pause the presentation, take a few seconds to write down any of these disadvantages that you can make out. So coming back again to the application of FITT to cardiorespiratory endurance, we asked you to look at the 220 minus age formula and to write down any disadvantages that you could see or any limitations you can see to that formula. Well, the first one is that it categorizes all individuals as having the same maximum heart rate regardless of their fitness level. So in other words, if you line up 20, 30-year-olds, you are assuming that their maximum heart rate is the same, no matter how fit they are. But it can be useful as a general guide when trying to find out a person's target heart rate zone or the heart rate zone that the person should train at. So why do we need to know an individual's maximum heart rate? Well, as I said, in order to determine the intensity at which the individual should train at, we refer back to FITT, which is the intensity. We're trying to find out the whole time 60 to 85% of an individual's maximum heart rate. And this is called their target heart rate or their training zone. How does it work? For example, Mary is 30 years old, so we're going to use the 220 minus the age formula to calculate Mary's maximum heart rate. So the first thing we do is we subtract the age from 220, so 220 minus 30 equals 190. So Mary's maximum heart rate is 190 if we use this formula here. The next thing we need to do is to find out Mary's training zone. So the first thing we're going to look at is 60%. So 60% of 190, you multiply 190 by 0.6 and we get 114. So the lower end of Mary's training zone is 114. So when Mary is training, we would at least expect her heart rate to be beating at 114 beats per minute at the lower end of her training zone. Moving on then, we're going to find 85% of Mary's maximum heart rate, which would be the higher end of her training zone. So we're going to multiply 190 by 0.85 and this gives us 161. So Mary's training zone is 114 to 161. And this means that Mary's heart rate should be up around this level in order for Mary to improve her cardiorespiratory endurance or to improve the efficiency of her heart and lungs. As I said, in order for her to improve her cardiorespiratory endurance, she must train between 3 to 5 times per week in her training zone, which we've just worked out, 114 to 161, for at least 20 minutes per session, and the type of training must be running, cycling, swimming, some kind of aerobic type endurance training. So, a task. I want you to pause the presentation again, and we're going to give you another little formula to work out. So this is John, he's 45 years old, and I want you to use the 220 minus the age formula to find John's maximum heart rate and also to work out John's training zone, which is 60 to 85% of his maximum heart rate. So you can pause the presentation and do that little calculation there and come back to it. Okay, so we're going to look at that little task that we got you to do. So 220 minus the age equals 220 minus 45, which was John's age, and we get 175. Okay, so 175 is John's maximum heart rate. To find out 60% of that, we could multiply 175 by 0.6, we get 105, and to get 85% multiplied by 0.85, we get 149. So the answer to the task was 105 to 149. This is John's training zone. This is the training zone that John must work out at when he is trying to influence or improve the efficiency of his heart and lungs, his cardiorespiratory endurance. Let's look at Mary's training zone then in more detail and see how we would apply it in programming. First of all, the percentage used while training Mary will depend on a number of variables. The first one being Mary's fitness level. So having done a fitness test on Mary, we would find out her cardiorespiratory fitness. If Mary was a sedentary client, then her fitness level mightn't be too good. We would start Mary off at 60% of her maximum heart rate. Otherwise, if Mary was quite fit, from a cardiorespiratory point of view, we might start Mary off maybe at 70 to 80% of her training zone. Her previous exercise history will determine where we start Mary in terms of training zones. So if Mary has been doing quite a lot of cardiorespiratory endurance work, maybe running, cycling, swimming, circuit training, whatever, we might decide to start Mary off at maybe 75% of Mary's training zone and see how she gets on. In the application of FIT, we would use the training zone in terms of intensity. So if we were trying to apply overload to the program, maybe Mary might have started off at 60% of her maximum heart rate, and X number of weeks down the road we would try and implement a little bit of overload into the program. We might bring her up to 65%, maybe 70%, and so on, depending on how she was feeling and how she was doing. And it is a stage of programming, so it depends on what stage we're at in terms of programming. If we're at week 1, Mary's a sedentary client, maybe her fitness level isn't too good, well then we'd be down at 60%. But X number of weeks into the program, we would hope that Mary would have gone upwards in her fitness level would have improved a little bit, and then we would try and maybe implement a little bit of intensity into the program and up the intensity to maybe 70, maybe 80% of her target or maximum heart rate in terms of her training and trying to improve it. Okay, so moving on to muscular endurance and the application of FITT, frequency, intensity, time and type again. Again, we're going to try and work out between 3 to 5 times per week. At an intensity this time of 60 to 70% of a 1 rep max for a novice to intermediate client, and 40 to 50% of a 1 rep max for sedentary or the older client. The time, well, as long as it takes to do between 10 and 15 reps. And the type is resistance training, it could be circuit training, it could be body conditioning. Coming back to a 1 rep max, we've already discussed in session 1, a 1 rep max is the maximum amount of force a person can lift during one repetition, and we would try and work out between 60 and 70% of this in order for a person to train for local muscle endurance. Another rule of thumb is that if somebody is doing between 10 and 15 reps of a particular exercise, for example a shoulder press, at rep 15, between 12 and 15, they should be approaching fatigue. And if they are approaching fatigue, we can assume that they are around 60 to 70% of their 1 rep max. So if it's not suitable to do a 1 rep max test on a client, there are other ways of finding where they're at in terms of their training. For flexibility then, we would recommend that you train 2 to 3 times per week minimum, up to 5 to 7 times per week for flexibility training. to the point of tension is the intensity here. And the time, 10 to 30 seconds and 2 to 4 reps per stretch. The type of stretching is varied. You have passive, active, active assisted and PNF stretching. And these types of stretching will be done in another module, so I'm not going to dwell on it here. The application of FITT to strength, 3 to 4 times per week, a minimum of 48 hours before working the same muscle group. In other words, rest and recovery is very important for strength training because that's the time in which the muscle gains its strength. 60 to 70% intensity of a 1 rep max for a novice to intermediate, moving up to 80% and above for experienced and advanced strength trainers. As long as it takes here in terms of time to do between 2 and 12 repetitions of each exercise, and the type is resistance training. Little task for you here for a beginner, week 1. How many reps do you think they would do of each exercise? So if you were trying to train somebody in terms of strength training, what would you recommend week 1 for the beginner to do? So take a few seconds there to think about that before moving on to the next slide. Well, the answer to the task was how many reps might the beginner do week 1 of a strength program would be 12. Because at the start of a strength program the weight is relatively low and therefore the reps are high. So it's quite similar to your local muscle endurance program. As the client gets fitter, the weight increases and the reps will decrease. So this 12 in a few weeks could become 10 and later on 8 and so on as the weight increases and as strength improves. Another task for you here. Given the description that we've just made here, what principles of training can you spot in this description? So take a little bit of time again, pause the presentation and have a look at this and see what are the main principles of training, or can you spot any principles of training in this exercise above. Well, what principles of training did you spot? Well, the first one you should have spotted was adaptation. As the client gets stronger, they can lift a heavier weight. Therefore, as the client gets stronger, the muscle adapts to the actual weight, and it's important to move on and make that weight heavier. Overload is another one that was applicable here. In order to progress your fitness, your strength, you need to increase the load to one which is greater than normal. So as the muscle adapts, you need to produce overload. And the last one was progression. As the individual gets stronger, the intensity needs to increase in order to achieve overload and achieve maximum strength. The application of FITT then to body composition. Frequency, 3 to 5 times a week, again for training, at an intensity of 60 to 85% of maximum heart rate and 60 to 70% of a 1 rep max for local muscle endurance. Now the reason we have two components of fitness here is that in order to improve our body composition, we would take a dual approach. We would work cardiorespiratory endurance coupled with local muscle endurance to burn calories, to reduce our level of fat, to improve our lean muscle tissue, and lean muscle tissue is more metabolically active than fat and therefore is more beneficial in terms of our body composition. It looks better when our muscles are toned, so to improve body composition we would work local muscle endurance as well. Time then for aerobic endurance, you would try and train between 30 and 60 minutes for moderate or 20 to 60 minutes for vigorous exercise in your exercise session. And again, for local muscle endurance, you would, in terms of time, it's as long as it takes to do between 2 and 4 sets of 8 to 12 reps of a particular local muscle endurance program. Your type then again, running, cycling, swimming, etc. for the cardiorespiratory, and then resistance and mainly compound exercises in your LME program to target as many muscle groups as you can in order to improve the tone and condition of the muscle. So that concludes session 2. In the next session, we're going to look at the stages of health fitness assessment.